Alrighty, hello everybody. Welcome back for the next installment, 1.3 Equations with Variables on Both Sides. Okie dokie. So what we're looking at today really is the difference between this equation, which has our x's both on the left side and just the number 10 on the right, and this equation, which now has our x's separated by an equal sign, both on different sides of the equation. Okay, and what do we do when I have my x's separated? Because in the last section, I was able to just combine like terms, and it was easy. But if I have them on different sides of the equation, it's not as simple to combine them. So, when variables are on opposite sides, you must move them by addition or subtraction until all variables are on one side and all numbers are on the other. Alrighty, should be simple enough, right? We're experts at manipulation of equations now. So let's look at example 1. 15 minus 2x equals negative 7x. Let's see if we can solve it. I need to get my x's together, and it's really up to me whether I want them to be on the left side of the equation or the right side of the equation. Each situation is going to be a little bit different, but you want to kind of check where are your numbers that are not attached to x's. See, right here I have a 15 on the left, so it's probably better and easier for me to move the x's to the right side because the left already has a number. So I'm going to just do inverse operations. I'm going to add 2x and add 2x to keep it balanced. On the left side, negative 2x and positive 2x, leaving just the 15. And on the right side, negative 7x and positive 2x gets negative 5x. Cool. Now I'm getting to good stuff. I mean, this looks really, really easy now. All I have to do is inverse operations to get the x completely alone, which means undoing multiplication, which is division, dividing by negative 5 on both sides to keep it balanced, which gives me negative 3 equals x. Negative 3, because this was a positive, divided by a negative, which makes this negative. Very good. So, checking your solution again is always a very, 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 very good practice. You should be able to say 15 minus 2, and then we're saying the x value that makes this equation true should be negative 3, equals negative 7 times our x value, which we're saying is negative 3, and this equation should come out correctly. All right, we should get the exact same number on both sides. This is 15. Negative 2 times negative 3 is positive 6. Negative 3 times negative 7 is positive 21. 6 plus 15, 21. Good job. Now, example 2 is when we get to some nice stuff, some really good, interesting equations. So, there are two different ways to solve these. I have the distributive property going on, and we've looked at distributive property, but I'm going to solve them in the two different ways, one where I do distribute, one where I don't distribute. So I'm going to draw a little line down here. I'll do the first one. Let's say the first one I will not distribute. And the other one I will distribute. Okay? This is just me saying randomly that I'm going to do it or not. So, in the first one, the first thing I'm going to do, because I'm not distributing, is to say, okay, this 3 is multiplying everything on this side of the equation. So, in order to undo it, I have to divide. I'm going to divide both sides by 3 first off. Let's just rewrite 3 times 5x plus 2 equals 15x. Divide by 3, divide by 3 to keep things balanced. What I get is 5x plus 2, because my 3's have gone away. That is a 5, equals 5x. Now, it wasn't totally random that I said that I didn't want to distribute over here. And then I was just going to divide by 3 first. I could tell that if I divided both sides by 3, that the right side would come out with a nice number, right? 15 divided by 3, I could see that was going to be 5. So if you can look a little bit into the future, you might be able to tell if dividing first is a good option for you, right? So now that I'm at this point, I now have to want to collect terms that are alike on the same side of the equation. I want to get my x's together, I want to get my numbers together. I have numbers on the left, so I might as well move my x's to the right. Inverse operation tells me I should subtract 5x minus 5x. Over here, exactly what I wanted. Positive 5x and negative 5x makes 0, so the 2 is just left. And on the right side, positive 5x and negative 5x equals 0. Uh-oh. We probably weren't all expecting that to happen. 2 equals 0 is a ridiculous statement because it's just not true. If it was true, well, I would be doing my job very, very, very wrong. The fact that 2 does not equal 0 tells us something about the equation. What it tells me about the equation is that there is no solution. There is no number that I could put into this original equation for x that would make the left side equal the right side. And you can go ahead and try. You can try any number that you'd like to, as long as x is the same on both sides. And it won't work. The left side will not equal the right side. Now, for part B, let's see if we get something crazy going on over there as well. Why don't I do this one? Yeah, you can see the green. In green, and I said I was going to distribute on this side. Okay, so the first thing I do is negative 2 times 4y, which is negative 8y, and negative 2 times 1, which is negative 2, and then the right side I didn't touch. Negative 8y minus 2. Uh-oh. Okay, now some of you might be thinking left side looks suspiciously like the right side, but let's ignore it for now. Let's say that we didn't see it and just continue on with what we would do. I would say, okay, now let's group together all of the variables and all the numbers. Okay, sure. Let's add 8y on this side and keep it balanced by doing that on this side, which means that'll go away, and okay, that'll go away too, which leaves me with negative 2 equals negative 2, which I guess is a step up from the last one, because at least negative 2 does equal negative 2. What does that imply? That implies that we have infinitely many solutions, which means any number that you put in for y in this equation will make this value on the left side equal the value on the right side. It will always work. And that really only happens when the two equations are identical, which we did see in this step. Alright, so we kind of got some interesting things going on here. Kind of just solving an equation the way that we used to up here with variables on both sides. We have a situation where there's no solution down here in example 2 part A. We have a place where there's infinitely many solutions in example 2 part B. Alrighty, example 3, multiple choice, beautiful thing. The circles are identical. They're different colors, but they're identical. What is the area of each circle? If they're identical, they should have the same area, right? Right? So how am I supposed to use the information that's here to try and figure out the area of the circle? Well, what's the formula for area of a circle, I guess? Area should equal pi r squared, right? So I really only just need the radius of one of these things, because they're both identical circles. However, the radius is masked in this x plus 2 idea, right? Or half of the diameter, which over here says that it's 4x. So I somehow have to figure out what x is in order to get the radius, which then I can take the radius and put it into the equation. So there's a couple of steps I need to take. First of all, let's try and figure out what x is. What do I know about a radius and the diameter? I know that twice the radius equals the diameter, right? So, by the same kind of logic, the radius would be half of the diameter. Well, over here it says the diameter is 4x, so the radius over here must just be 2x, right? And if these things are identical, shouldn't this radius be the same as this radius? So shouldn't x plus 2, the radius of the green circle, be the same and equal to the radius of the purple circle, 2x? It should be. So now we have an equation, variables on both sides. Let's solve for x. I'll subtract x on both sides to try and group together my like terms. That'll get rid of it over there, leave me with just a 2. And 2x minus x leaves me just one of them, 1x. So x equals 2. That's fantastic. I have x. Should I just take this value and put it in for the radius? Some of you might do that, and it is not the correct thing to do. X is not the radius. The radius is x plus 2. So the radius equals x plus 2. Radius equals 2 plus 2. Radius equals 4. Now I can take that over here. So the area is going to equal pi times 4 squared. What is 4 squared? Squared means take that number, multiply it by itself. So pi times 16. Does one of these say 16 pi or pi 16? Whoop! C. Beautiful. Alrighty, using a little bit of logic in there. Last example, real life example. Here we go. A boat travels X miles per hour upstream. Let's use blue for that one. The speed going upstream is X miles an hour. On the return trip, the boat travels 2 miles per hour faster. On the return trip, I'm about to run out of battery. Alrighty, sorry about that. Now that I've satiated my rude computer's thirst for electricity, we can get back to what we were doing. On the return trip, the boat is traveling 2 miles per hour faster than it was on the outgoing trip. So this way, I'm going to be going the same speed plus 2 miles an hour. Okay, cool. How far does the boat travel upstream? Hold up. You didn't mention anything about how far it was going. We were talking about speeds here. How am I supposed to figure out how far it traveled upstream if we were just talking about speeds? Well, I need to take a step back and really think about this. The distance that he travels away must be the same as the distance of the return trip. I mean, if you're leaving somewhere and then coming back, right? The distance that you go has to be the same distance as the distance that you return. So with that in mind, how can I represent distance given the speed? Well, we kind of know this idea that the rate at which you travel is distance over time, right? At least most of us should be familiar with that idea. Like, even when you say something like miles per hour, that's always doing a distance of miles over a specific amount of time, hours, and that's telling you your speed. So by the same type of logic, if I just move this thing around here, I should be able to say that the distance is equal to the rate times the time. Okay, so that gives me a little bit of something if I remember that the two distances have to be equal to each other. So this should be the distance upstream, which would be the rate, which we're saying is x, times however much time you were traveling, which according to our nifty diagram here says that it was 3 hours. So 3 times x on that side. And this should be the distance of the return trip, which should be the rate, which we were saying was going to be x plus 2, times however much time it took you to get back, which according to our nifty chart here is 2.5. All right, now it seems like we might actually be getting somewhere here. now that I have an equation that I can try and solve, I think I can get x, and x is supposed to be the um, miles per hour upstream. All right, let's see what we got. We got 3 times x and 2.5 times x plus 2. I'm just going to distribute. I think that's the easiest way to go, first of all. So 2.5 times x, 2.5x, and 2.5 times 2 is going to be 5, and that's going to equal 3x. So now what I want to do is I want to try and combine all of my like terms. That means I'm going to subtract 2.5 on the left side and balance it out by subtracting 2.5 on the right side. That leaves me with just half of an x being equal to 5. Okay, now I have 0.5 times x equals 5. So that means I'm going to divide in order to take away that multiplication and undo that. So dividing by 0.5, divide by 0.5, and that leaves me with x equals, how many times does half go into 5? Well, half goes into a whole twice, and then that whole number 1 can go into 5 times. 2 times 5, 10 times. Very, very good. So now I know that x equals 10. Is that my solution? X miles per hour. X stands for the speed. What was I being asked for? How far does the boat travel upstream? Okay, so how far does it go upstream if it's going 10 miles an hour for 3 hours? 10 miles an hour for 3 hours means that it goes 30 miles. Fantastic. Alrighty. Good luck with the assigned work. Remember to write down any questions that you have. I will go over them. We will fix it. We will make it work. And I will talk to you all later. Fare thee well.